I'm going to do one more example, but I want to talk about one extra feature that's nice when we have binomial models that we haven't talked about yet. So, terrifyingly, 91% of all email is spam. Your inbox has 25 emails. Find the mean, standard deviation, and the probability that one or two of the emails are not spam. Now, this is just like one of those cool little things about binomial models that maybe makes sense, maybe doesn't, but it is fun to play with. So when I think about this, how many real emails do you expect? That's really saying what's the average or what's the mean number for real emails? And that's very easy to figure out with a binomial model problem because we just do n times p. And so in this case, that's going to be 25 times 0.91. Oh, except I want to do that they're not spam. Whoops. Which makes sense because for me, when I answer my email, success is definitely a real email, right? It's not spam. So we want success here to be not spam. So the probability of not spam is 1 minus the probability that it is spam, which is 1 minus 0.91, which is 0.09. So to figure out this average, I want to do 25 times 0.09. That's how many real emails I'm getting. And this ends up being 2.25. So I'm expecting, somewhere between 2 and 3 of my emails to be real emails. Okay, maybe a little closer to 2 than to 3. That's what I'm expecting. Now, we can also figure out, this is something that's less used, but it's nice to talk about, the standard deviation of how many of these emails are not spam. So just so that you know, and you have this formula, the standard deviation, we do the square root of n times p times 1 minus p. So in this case, that's going to be the square root of 25 times 0.09 times 0.91. And when I put that into my calculator, I get 1.43. So this is the average, that's the mean, and this is the standard deviation for the number of real emails. Now, we also want to find the probability that one or two of these emails are not spam. We haven't talked about checking the requirements, so let's do that now. Do we have a fixed number of trials? Yes, we do. We are looking at exactly 25 emails. If one new one comes in while we're doing the calculations, we're not going to include it because we need a fixed number of trials. We need for there to be two outcomes. And we've already talked about that. Success in this case is a message that's not spam. And failure is a message that is spam. Okay, so we've got two outcomes met. We also need that same probability of success at each turn, and we've got that because P, the probability of our real email, is 0.09, and we talked about that up here. And the last thing that we need is that these are independent. And that's the one that's, maybe a little iffy. We're going to say that it's met. But you could imagine maybe I'm having a big email conversation with somebody in my life and I all of a sudden get 15 emails back and forth with that person. Those might not be spam. So, there's a little bit of a like, we're going to assume that it's independent, but maybe it's not. Okay. Now, if we want to find the probability that one or two of these emails are not spam, so probability 1 or 2 are not spam, well, that's going to be the probability that 1 is not spam plus the probability that 2 are not spam. And each of these we can figure out with a binomial model calculation. So this first one is going to be binom PDF. Our number of trials is 25. Our probability of success is 0.09, and we are looking for one success. We are going to add to that Binom PDF for 25 trials, 0.09, common mistake, 0.09 probability of it not being spam, and 2 successes. And we're going to put each of these into our calculator. When we put the first one in, we get about 0.234. When we put the second one in, we get about 0.278. And when we add these together, we get 0.512.